All right, so this one, something that's very popular, College Board, they like to take some of these area and volume questions. Sometimes they like to expand them to improper integrals, or they like to take BC or AB topics, and then they try to put like something BC with it, which means, taking an integral to infinity is kind of what's happening here. And so it says, this one says, determine the volume of a solid when the unbounded region W is rotated around the x-axis. So we have this region that goes from 3 to infinity. So a couple things here. If we were just going to find the area, like the area of region W, it would just end up being this integral from 3 to infinity of, x to the negative second dx, right? This would just give us the area, okay? And we'd be able to compute that if we wanted to, okay? So just be aware of that. If we were going to find the volume, we have to think, when this is rotated around, what's the cross-section going to look like? All our volumes, remember, our volumes are always going to be this integral of the area of the cross-section times like dx or dy, whichever one, from x1 to x2. This is how we're going to find all our volumes. It's going to be some sort of area of a cross-section, dx. Well, what's the area of this cross-section when this w is revolved around the x-axis? Circle, right? It's going to be a circle. So we have this radius right here, and then it's going to create a little circle right like that. And the thickness of that, like in the, because it's going to be a very flat figure, that circle, the little cross-section is going to be a two-dimensional shape. When we multiply it by dx, it's infinitely thin in the x direction. You can see that from the radius. When I draw the radius right here, when I draw that little radius, I can see that length is in the y direction, but that infinitely thin width of it is in the x direction, telling us it's going to be a dx integral. So our volume, we're going to start with a dx, and we're going to go from x equals 3 to x equals infinity. So realize when we have a dx integral, your bounds are definitely going to be in terms of x. And then we got to think of the area of the cross section. Well, the area, we said over here, the area is going to be pi r squared, the area of a circle, right? And so that r value, if r is just a length, which is calculated by going top minus bottom, right? If we're going to find a length between 10 and 3, we would say it's 7, because we did 10 minus 3 is 7. So in this case, we're doing this function minus 0. And so it's just going to be, this length is going to be 1 over x squared minus 0. And so we'd end up with pi 1 over x squared. So we have our pi r squared dx. And this integral right here would give us that volume. Now, how are we going to compute that? Now, if you're going to do this on a free response question, they're not going to want you to leave this improper, okay? If you're doing it on a multiple choice, no one's grading your work. So if you want to plug in infinity, do it all you like. It's not proper math, but no one really cares on multiple choice. On free response, they're going to want to see the limit. So you're going to have to convert this and say this is the limit as, say, a approaches infinity of the integral from 3 to a. And I'm going to go ahead and pull the pi out of my integral, and then realize this is going to end up being x to the negative 4th dx. This is not a 9, this is an a. All right, now I'm going to do my antiderivative. So I still have the limit. Let's not lose those limits, okay? Because they're going to, if you forget to put a limit in there, then you get what they call linkage error, and they're not going to count your work, right? Because your work, you no longer is maintaining the equality from step to step. And so you end up with this x to the negative 3 times what? Negative 1/3. So we're going to say negative pi over 3. We'll have all that evaluated from 3 to a. And so we have this limit as a approaches infinity of negative pi over 3a cubed minus negative pi over 3 cubed. Everybody go with that? And when we apply this limit, what's going to happen to this first term right here? 0, right? We're dividing by infinity. So pi divided by infinity is going to be 0. And then over here, we have minus and negative, make sure we realize we have the minus from the fundamental theorem. We've got the negative from our antiderivative. We got to make sure we don't skimp on one of those and we forget one of them. So we got to make sure we have both negatives so we become positive. And so we end up with this pi over 81. Also realize if you got an answer of negative pi over 81, is that even a reasonable answer for a volume? No. Okay. So think about all your area and volume questions. They're going to have positive answers. Okay. Any questions over that?